Next, let's take a little bit more detailed look at how the traffic diversion and injection can be done on the cleaning center. This is our management center. Our cleaning center can either be inline or it can be offline or out of path. This is an inline deployment where the cleaning center is sitting in line. The traffic is passing through the cleaning center. As soon as the detecting center instructs or informs the management center that an attack is happening, the management center is going to instruct the cleaning center to start cleaning the specific traffic. And the cleaning center is going to start cleaning the traffic without having to inject any routes, because in this case it is sitting inline. It's an inline deployment and all the traffic is going through the cleaning center in any case. And we can, for redundancy's sake, for high availability, we can have redundant, or we can have two cleaning centers acting together for providing high availability features. The second option can be the offline or out of path deployment, where the cleaning center is not deployed inline. In this case, when the detecting center detects, because of optical splitting or mirroring, any attack, it is going to inform the management center. The management center is going to instruct the cleaning center, and the cleaning center is going to inject a route, a host route here on the server using BGP. We can also configure a static route manually on the router, but that's not a desirable way, because that requires manual intervention. The best way is to inject the route using BGP. A host route is injected for the destination, and the traffic is diverted here. Once the traffic is cleaned, then the traffic is injected back into the network by the cleaning center. We can have different injection mechanisms as well. For example, we can have policy-based routing, or we can have a static route as well. We can configure a static route, or we can have VPN implemented here, GRE or MPLS VPN, using which we can send the traffic to the destination. However, the most desirable mechanism is the policy route, forwarding traffic using the policy route. As you can see, the desired or the preferred traffic diversion mechanism is using the BGP dynamic routes. The disadvantage is that it's slightly complicated, complex to configure BGP and configure diversion using BGP. However, this is the most reliable way. Similarly, the injection mechanism, when we inject the traffic back into the network, when the cleaning center injects traffic back into the network, the most desirable way is using the policy-based routing. The disadvantage of policy-based routing, once again, is that it is slightly complex to implement, but it's the preferred way, and we should always rely on policy-based routing. Then another component of this Huawei solution is the NFA, where we use net flow analysis engine. We can use Huawei's NFA 2000V, which can be used for flow-based analysis and flow-based detection. As you already know, that we can either have per packet detection, which can be done using the detecting center, or we can have a per flow detection using the NFA. So if the amount of traffic in our network is large, then the per packet detection becomes slightly difficult, because there's a lot of traffic that is being exchanged in the network, that is going through the network. So in that case, we can prefer, or we can use the per flow detection. And if we use per flow detection, then we can use the NFA component. This is what is going to happen. We have Huawei's NFA 2000V. The traffic is, net flow traffic is coming from this router to NFA 2000V. It detects, as soon as it detects an attack, it informs the management center. The management center instructs the cleaning center, and the cleaning center can start the traffic diversion, cleaning, and then injecting the traffic back into the network. The rest of the process is the same, except for that we are using, or we are detecting the traffic, not using the detecting center, but the NFA 2000V, which is based on NetFlow or Huawei's NetStream architecture. This is a block level representation that traffic is received by the NFA NetFlow analyzer using either NetFlow which is standard base or Huawei's NetStream. It checks the traffic. The traffic goes through all the checking mechanisms. If the traffic is detected based on these mechanisms, if the traffic is, after this analysis, if the traffic is detected to be attack traffic, the NFA is going to inform the ATIC server, and then the ATIC server can perform the necessary actions through the cleaning center. So this is all about the Huawei's anti-DDoS solution. And finally, let's take a look at the firewall's features to act as an anti-DDoS device. We know that firewall can do a lot of things. Huawei's firewall is a very versatile device. It can not only protect us against, it can not only perform normal firewall operations, but it can also protect us against single packet attacks and DDoS attacks, whereby the normal traffic will be allowed to go through. However, if there is an attack traffic coming in, or if an attacker is trying to send single packet attack traffic or DDoS attack traffic to the intranet, to our infrastructure, the firewall is going to block this traffic. The different detection or defense technologies which the firewall uses are the source detection technology, the fingerprint technology, traffic limiting technologies. These technologies we have already discussed. The only point to understand here is that these technologies can be used for implementing defense against different types of attacks, and the firewall or the USG firewall supports all these defense technologies. And the last slide of this module, this is just to summarize of how the firewall defends our network against the DDoS attacks. It's a very simple slide which is summarizing the firewall DDoS defense mechanism. The firewall is going to do traffic statistics analysis. If the volume of traffic exceeds certain predefined or specified threshold, the defense mechanism kicks in, and the firewall defends our network against that attack traffic, and the appropriate defense actions are taken, and the traffic is probably either discarded, or the rate limiting of the traffic will take into action and will be responsible for defending our network. So this will ensure that the firewall is defending our network against the DDoS attacks. So this was all about the network attack defense policies or network attack defense strategies, in which we looked at different types of attacks, and we saw how we can defend against those attacks, whether those are single packet attacks or those are traffic attacks, or what we call the DDoS attacks, either on the DDoS, anti-DDoS defense solution of Huawei, or using the USG firewall. I hope this module was informative for you. You learned some new technologies in this module. We'll see you in the next module. Thank you.